Hello everybody, this is Aaron Schwartz, and we're looking at a video where we're going to do a brief comparison of solving by square roots with other methods of solving quadratics. In Unit 4, Topic 2 and 3, students learn about the structure of quadratics by exploring patterns in diagrams, tables, and graphs. Some of the key ideas include that quadratic equations can be solved by completing the square, factoring, graphing, and other methods. So let's take a look at a typical quadratic equation that we would want to solve. We're going to solve this two different ways. We're going to solve by square roots and the quadratic formula. Now, we should point out up front that the numbers that we've used are going to work out in a particular way. And that's just so that we can contrast the two different methods. There are times when the quadratic formula may be a more appropriate effort than completing the square. When you do the quadratic formula, you've actually completed the square for any quadratic with the terms a, b, and c. But when you're dealing with all sorts of irrational or otherwise fractional values, it's often easier to just go straight to the quadratic formula instead of solving by square roots. Let's start by solving by square roots. The first thing I want to do is factor out that 2. I have this nice quadratic equation with very simple terms. I have 2 times the quantity, x squared minus 6x plus 5. I'm going to go ahead and complete the square on that x squared minus 6x plus 5. In this case, a pretty simple one. Half of negative 6 is negative 3. Negative 3 squared is 9. 5 is 4 less than 9, so I'm going to have a minus 4 term in there. I can divide both sides by 2, and I just have my quadratic, the square of x minus 3 minus 4. I can now add, take the square roots, and for this video I'm going to leave it as the square root of 4, even though the square root of 4 is a nice rational number, 2. I'm going to leave it as the square root of 4 to compare some structural things later. And I can add my 3, and I end up with this answer, 3 plus or minus the root of 4. Now let's take a look at the quadratic equation. There are different ways that the quadratic equation is often expressed. This may appear as a more complicated version, but it sets up for some nice comparisons later on. The basic structure that's represented here is that the quadratic formula gives us our axis of symmetry for our parabola plus or minus a distance to each of the x-intercepts. So I'm going to go ahead and substitute in all those numbers. And there's a lot to substitute in. I have to substitute in for b twice. I have to substitute in for a 3 different times. And I have to substitute in for c. After I've done all that, I need to spend some time doing some calculations to simplify what I have. I'm going to get rid of that double negative on the term that represents our axis of symmetry. And so we just have 12 over 4. I've got to do some squaring and some multiplication. And so I've got, within the square root, 144 minus 80 over 4 times 4. When I simplify that even more, 12 divided by 4 is 3, and I'm doing the square root of 64 divided by 16. 64 divided by 16 is 4, and we end up with 3 plus or minus the square root of 4. One of the things that students may immediately notice when we compare this method is that that's a lot of work in the quadratic formula, where it was rather simple when we were doing completing the squares. This is an important observation, but it's also important for students to recognize that completing the square was particularly easy for this quadratic function because all of the numbers were integers, all of them were rational integers, and all of them shared a common factor of 2. That made it much easier to do the completion of the square versus the quadratic formula. There are circumstances where going right into that formula is going to be much easier for students, but it's up to the students to figure out when. This is only accomplished by giving students a lot of different examples of quadratic functions and having them articulate when it was easier to solve each type. I hope that this video helps teachers create classrooms where students explore math, observe patterns, and develop conceptual understanding. If you have questions, comments, or have a video idea, please email me at the address below.